here's our plan. Today we're going to be, we talked about writing last class, and writing is kind of weird, kind of difficult. We're going to keep practicing that. Ethan, get your packet out. Now. Okay. Today we're going to talk about solving systems by graphing. So that's why I said you'll need a ruler, because we are going to be graphing. Graphing is not new. It's something that we've done before, so that part won't be too crazy. I am going to show you some cool stuff to do in the calculator. Again, we're kind of at the spot where we've done everything by hand a lot, and now we're at the point where, like, hey, sometimes we can use our calculator to help us with this stuff. So if you don't have a calculator, you need to get one. Okay? Yes. Hold on. Yes. So, like I said, it's not a whole lot of new stuff today. We'll really get into the newer stuff when we get back from break. And we will continue to review this stuff because I know that you guys are learning this right before break, and it's going to take, a long while before I see you again. But we are going to move on. So we are going to do page 5. There's 2 warm-up questions. And we're going to go back. I skipped some graphs last time. We're going to go back and talk about those just briefly before we get into the new stuff. And again, we'll get through this. It seemed the notes seem like several pages, but it's because there's graphs and they take up a lot of space. It's really not too many problems. So this is a review of the writing, okay? And this is a STAR question, and there are a lot of STAR questions that involve writing. Most of the time, the ones I've seen, they are multiple choice. And I think that will kind of help you reason through this stuff. So let's just go ahead and kind of read our situation and think about what we did last time, okay? So a customer paid a total of $6. I'm going to circle that. Total of $6 for 68 copies. I'm going to circle that because those are numbers that I'm going to need to use. One of them is a money amount. One of them is the number of copies. Some of the copies were black and white copies. The rest were color copies. Each black and white copy cost 8 cents. Each color copy cost 15 cents. Okay, so these are money amounts as well. I'm going to circle those. Now, here's what the STAR test typically does, and I do like this because I think that this is really helpful. They usually will define your variables for you. So if you look at this next little sentence, it says, which system of equations can be used to find B, the number of black and white copies, and C, the number of color copies. So that's always our first step, is what are our variables and what do they mean? And what's nice about questions like this are that they tell you, okay? So we know what those are. We're talking about black and white copies and color copies. So when we write our 2 systems, we need to put all the information together. Now, there's 3 numbers here that have a $sign. Those 3 numbers, those are money values. Those need to go together. So we're going to have a money equation. Okay, and then the other number that we have is 68 copies. So we're going to have a copies equation. That's kind of how we're sorting through here. Okay, so if B represents the number of copies and C represents the number of copies, then what does B plus C have to equal? $6. Copies plus copies equals dollars? 68. Copies plus copies equals copies. So black and white copies, colored copies has to equal 68 copies. Copies, copies, copies. Okay, so if you look at A, B plus C equals $6. Does that make sense? No. Mark it out. B plus C equals 68. Possible. C, B plus C equals $6. Bye-bye. And D, B plus C equals 68. So we're 50-50 now. It's B. Now we need to put the money values in. How much is a black and white copy worth money-wise? 8 cents. So 0.08 B plus a color copy is 15 cents per color. And what's the total money? $6. So the difference between B and C is they just have the money values swapped on one of them. So what is the correct answer? D. Okay, so again, I hope that you're starting to see these and yes, they look scary because they're word problems and those freak people out. They freak me out. okay? But sometimes, especially if it's multiple choice, just reasoning through and just like, oh, that's copies equals money. That can't be there. That's copies equals money. Throw it out. Oh, this one, they put the wrong money value with the wrong variable. That's kind of usually how they set them up. And so, again, when you have these answer choices, they're not always too bad. And that's how you would go from there. Copies, 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 money, money, money. Does that make sense? That's not that bad, okay? All right, this one gives you two tables, and they ask you to write the system of equations. So this is actually something that we're going to talk about today. But let's just pretend right now that we only have line F. So cover that up with your calculator. Just pretend we only have one. This is what I had y'all do a little flips lesson on after the test. Y'all remember doing the stat thing in your calculator?
Yeah.
Okay, let's review that real quick. First thing, I want everyone to clear their calculators because my Algebra 2 kids have been testing and they might have some different stuff going on in the calculator. So second plus 7, 1, 2. Just go ahead and reset them so we can all start kind of in the same situation. So our last test that we already went over and everything, I had you guys find the slope, put it in point slope, convert it, and y'all did great. So I know y'all can do this by hand. But now that we're kind of to the point, hey, we've mastered that, I'm going to show you another way. That's going to be a lot quicker and a lot easier, and it's something that you're going to do a lot on the STAR test. Okay, it's a really, really big thing. So that is running a linear regression. Okay, that's what we're doing in theory is a linear regression. I oftentimes abbreviate that to STAT. Okay, so we are going to put our tables in, and we're only going to do one at a time. That's why I covered up line G, and we're just focusing on line F. We're going to put that table into our calculator. And if you remember from the little video, to do that, we're going to use this button right here, which says STAT. So it's 2 over from alpha, the green one. So press STAT. And then if you remember, you have to select press 1 or press enter. But the first thing you have to do is do STAT edit. You have to put the table in. Since we've just cleared our calculator, you shouldn't have anything in your table right now. Okay? So we're going to put our x's, our x values go in L1, our y values go in L2. So we're just going to type our x's, 2, enter, 4, enter, 7, 11. And then scroll over, and we're going to put our corresponding y's, 7, enter, 10.5, enter, 15.75, 22.75. And we're going to put all those numbers in, and we should be looking at the same exact thing as we have on our calculator, our table. Does anyone not know how to do this so far? Nick, are you with us?
I'm with them.
With us? Okay. All right, so I want to put that in. The only thing that I really feel like could cost you here is if you make a typo. So just be very careful. Don't make a typo. Double check. You need to put all the points. Make sure we've got everything good and right, and we're ready to go. Okay, so that is what we do first. Stat edit, x is in L1, y is in L2. Then what do we do?
Then you press stat again.
Stat again.
Oh, wait, no, calc.
Stat, you got to go right to calculate. Scroll right. So once you put the data in, you're actually going to calculate something. And then we're going to choose number 4 today. By the time you get next semester, we're going to have some other options. But for the rest of 2020, what year are we in? 2023?
Yeah.
Okay, we're going to be choosing Stat Calc 4. Okay, and it says linear regression. So you can either scroll to 4 or just press the number 4.
How do you get there?
Go back to Stat. Scroll right to Calc. At the top, it says like Edit Calc Test.
Yep.
You go to Calc. And then you choose 4.
And you press enter.
Okay? So you shouldn't change. Your screen should look like this. Are you there? Okay? You don't need to change any of this. Don't mess with that. Just kind of either enter through it or scroll down. You want to get to calculate. Calculate is where we're trying to go. So enter all the way through, calculate, and here's what this gives you. It's going to give you this screen right here, and it's going to say linreg at the top because we did a linear regression. That's what we're doing for the rest of 23. It's going to say y equals ax plus b. That's how we're going to write that equation together, and then it's going to give you an a and it's going to give you a b. Why it doesn't do mx plus b, I don't know. But when you do the regression, your a value is your m. So what is the slope of this guy? 1.75. So it's kind of it's in the same place as the front of the x. They just don't call it the same variable in the calculator. So for our first one, we get a equals 1.75, b equals 3.5. So how do we actually put that together as an equation for line F? Y equals what? 1.75 x plus 3.5. Okay, that's the equation for this line. The slope is 1.75. What's the y-intercept? 3.5. The b. That's the same one. Okay? So can we eliminate any answer choices here?
H and J.
H and J. Knock them out. All right, so now here's the thing. This problem technically had two tables. So we're going to do the same thing, but with the other table. Okay? So let's talk about line G. So go back to stat, edit. I don't know if the video showed this, so make sure you're on this screen with me.
Oh, can I already delete it all?
I want to show you a faster way to delete them all, okay? Everyone back to stat, enter. Okay, you can scroll up and highlight where it says L1 or L2. It doesn't matter which one you do first. I'm in L2. So highlight that. And then if you see the button clear right here underneath the down arrow, if you press clear, enter, it takes everything out in one time.
That isn't working for me.
Okay, let me look at it.
Wait, never
Clear,
mind.
then, yeah.
You have to like scroll up and highlight. Do not hit delete. I want you to hit clear, enter. You don't ever want to delete your list. You can delete individually in there, but if you want to wipe them all out in one step, just clear. Did it work?
Yeah.
Okay, so now retype line G. Same exact thing. X is in L1. Y's in L2. And honestly, this is about like 1/3 of the things we're going to cover on the lesson today. So we're kind of already getting our lesson started. And you're going to calculate a linear regression again.
They didn't give me the answer.
Let me see. This is part of what we're doing in the lesson, so I figured I might as well kind of write it all out here. And so here's my other equation, negative 4x minus 8. So my answer is F. What's the slope of this line? Line G. What's the slope?
4.
What's the y-intercept?
Negative 8.
Another 8.
Negative 8. Negative 2 is the x-intercept. So you can use stat to find the slope or even find the intercept. Like that's what that tells you. It gives you your slope-intercept form, or you can just find pieces of it, just depending on how that works, okay? So we will come back to this. You will do this on your test, and hopefully it'll be easy and fast, and you can get all those points right. Flip back now to the second page. There was 2 graphs on here that I skipped. Number 5 and number 6.
This is the last thing we're gonna do.
No. And we are going to kind of just touch on this, and then we'll get into the actual graphing side. Okay? So page 2, like it's back to last lesson. I'm going kind of backwards for a second. And we didn't do 5 and 6 last time. Okay? So 5 and 6, they give you a graph, and they want you to write the equation of the graph. Again, we've done this. We have done this. This is a review. Well, the 2 things we need to write the equation of a graph in slope-intercept form. We need the slope, and we need the y-intercept. So let's look at our equation right here. How do I know that this graph is an equation? Well, it's not an inequality. It's an equation. The problem says write the equation. And also, is there any shade on this graph? No. So it's got to be an equal sign. But this guy, there's shade. So we'll be talking about that in a minute. So what is the y-intercept to this graph? Negative 9. Is our slope positive or negative? Positive because it's going up. And let's calculate the slope. We're looking for a good point. Is the next good point 4? 4, 0. Is that what y'all got as the other good point? The x-intercept?
That's a big slope.
That is a big slope. What is it? How many did you go up?
9.
7, 8,
How many did you go over?
9.
4.
4. Does 9 over 4 reduce at all?
Nope.
No. So what's your slope-intercept form?
Y equals 9 over 4 x minus 9.
Okay, that is not going away. Being able to do this with a line is not going to go away today. The only thing that is different about a system is that you're going to have 2 lines. So you're going to do this process 2 times. Yes.
I did like 2 different points. I got a different answer.
What other point did you use?
I did 5 and then 2.
5 and 2. Let me see. For the other graph on number 6, it says write the what?
Inequality.
Inequalities. So again, we're going to kind of bring back inequalities a little bit today. So remember, inequalities, they have dashed or solid lines, and they have shading. So we still need the M and the B, but we also need to talk about the line type and the shade. So what type of line is this? Is this dashed or solid?
Dash.
Dash. So let's go ahead and start with that. And then where is the shade?
Below.
Below. Dashed and below. So what symbol am I going to use?
Less than.
Just a less than. Very good. Okay. Remember, equal tos mean solid line. So I know I'm not going to have an equal to because this guy's dashed. Shading below. Shading below is going to be a less than. Shading above is going to be a greater than. So we need to know which symbol we can use. And then we've taken care of this. And now all we have to do is the mx plus b. So what is the b? Looks like it's positive 7. What kind of slope is this? It is negative. It's going down. Okay, a good point. Again, these graphs are so tiny. I think another good point might be 5, 6. Do y'all agree with me?
Yep.
Yes.
So what is that slope? Where did I go on the y? Down 1. And on the x, I went over 5. So my slope is negative 1 over 5. Whew, tiny graphs. Hurt my eyes this morning. So my slope is negative 1/5 x plus 7. Okay? And what was different was that I had shade on my graph, so I didn't have an equal sign. I had to pick my inequality sign. Okay? And we're going to come back to that. All right. Let's jump to page 6. Page 6. Yeah, I know. Okay. All right, we're going to talk some definitions here because, again, we're spending a lot of weeks on systems of equations. And we're going to have several methods to solve systems of equations by the end of it. But I need you to understand what it means to solve a system and understand what we're looking for, whether which route we take, okay? So to solve a system of equations means, like big picture, we are finding the point that the lines intersect. So let's fill that in. We're going to have them on a graph.
What page?
Oh, page 6. Went back to page 6. So finding where the lines intersect, which intersect means the same thing as cross. Okay, so you're finding where the lines cross. Graphically is the most visual example that you can see, and so I do think that this is a good one. But that's, you're finding the solution. Solution is always what we're looking for, and your solution is the point, and it is a point. It will be an ordered pair of intersection. So if it says solve the system, find the solution to the system, you're looking at where are my lines crossing, okay? No matter what method you take, that's technically what you're finding. It is a point, so I put parentheses. So no, there will be an x value and a y value, and both of those are your answer. So remember, a system means 2 equations. You're You're going to have two parts put together as your point of intersection. Now, there's three different cases that you can have for solutions. And so the most common case is you have two lines that will cross. And that means that you're going to have one solution point. And I'll draw an example for you here. So you're going to have lines that cross. And so that would be your one solution. Okay? So I drew a little picture right there for you, visual representation. But you can have a couple other cases. You can have lines that are parallel. And what do we know about parallel lines?
That they're the same slope.
They have the same slope. What else do we know about parallel lines?
That they don't intersect.
They do not intersect. So if you have two lines that do not intersect, do they have a solution?
Nope.
No. So you might have a case where there is not a solution. And that means that those lines you're looking at are parallel. Ethan, I want you to fill this in. Fill this in. Stop what you're doing and fill this in. Okay? Then you have the case that the lines are the exact same line. Now, they may not look like they're the same line if you just look at the equation, but they are. So they share every point. So how many is that, Zane? All, or sometimes it might say infinite solutions. Infinite. Infinity points. And in that case, you would have a line, and then you would have another line. I'm going to try to kind of draw a little bit darker. Just one line on top of each other. They have all the points in common. They are the exact same line. Again, our most common case is that they cross one time. So this is what we're going to find. Majority of the time, we're finding one solution. But it is possible that you could get some cases, and we'll see them, that there's not any. Okay? So there's three possible methods. The method we're going to focus on today is graphing. That's the whole point of today's lesson. I'm going to point right here to this note. And then what we're going to work on after break is our other two methods. One of them is called substitution. There's Thanksgiving break. And then the last one is called elimination. So you're only learning graphing today. The other ones are later. You can see them in the calendar when we'll go over them. It's when we come back from Thanksgiving. All right? So I put a note right here that it says to use the graphing method when your equations are in slope-intercept form. Just remember, slope-intercept form looks like this, or could easily be converted, okay? So what we're going to get to eventually is once you know all these methods, you're going to have to choose which one is the most appropriate. And we'll talk about, hey, this should lean towards graphing, this should lean towards substitution, this should lean towards elimination. So for today, if we have our two equations and they are in y equals, then that is probably going to be, let's do it by graphing, okay? So we've got two graphs to do, and then I'm going to show you how you can also do this in your calculator. So let's review how to graph these functions, okay? Y equals negative 3/2 x minus 9. Y equals 5/4 x plus 2. Are these both in slope-intercept form?
Yeah.
So I would say SI form, which means I'm going to graph. Also, I'm telling you to graph. We're graphing today, so just FYI. That is the plan. If they give you a graph, probably would use it. Now, we're just going to graph one line at a time. There's two. We're going to graph one at a time. So let's start with the first one. I'm going to call this Y1. And put a little 1 right there because it's the first line that I'm graphing. It doesn't matter which one you pick as your first. It's your favorite. What's the y-intercept of Y1?
Negative 9.
-9. So I'm going to go down to -9, and I'm going to put a point there. My y-intercept. This is my B. What is my slope of Y1? -3/2. Now, I don't have room to go down 3. So I'm going to have to go up 3 from here. 1, 2, 3. But since I have a negative slope, which direction do I have to go on the x? Left. 1, 2. Do y'all see what we did there? If we go up in the positive direction, then to get our negative slope, we have to go left in the negative. And then I'm going to continue that pattern. Up 3, left 2. Up 3, left 2. That's enough points. I can use my ruler, draw my line. We're graphing.
Wait, isn't that a negative thing?
It is. Well, okay, so it's a negative slope. You can put the negative either with the 3 or with the 2. I didn't have enough room to go down 3, so I just went positive 3, negative 2. Positive 3, negative 2. And then you can look, the line's decreasing, which that should make sense. I'm just going to call it y1 over here so I know which one it is. Okay? Now, the only thing that's different is, hey, we're going to graph another line and we're going to graph it on the same grid. Same deal. This is going to be y2. What's y2's y-intercept?
2.
2. So I'm going to start at, it is a function. It's going to start at 2. Now, what is y2's slope? 5 over 4. Now, I have room here. I can go up. 1, 2, 3, 4, 5. Positive. And I can go which direction 4? Positive 4. 1, 2, 3, 4. Okay. I can't fit another point this way, but if I go back to the y-intercept, okay, so if I have a positive slope, that means I either have positive over positive or what else? Negative over negative. I can go down 5, 1, 2, 3, 4, 5, and left 4, 1, 2, 3, 4. What happened then?
Not a function.
It is a function.
No, but the lines are crossing.
That's okay.
But
That's,
I thought that's not a function.
no, functions are when the x values repeat
Oh.
on the same graph.
Okay, yeah, it is a function.
These are two different graphs.
One solution.
There is one, oops, this is y2. There is one solution. Zane, turn around. There is one solution. The lines intersect, so there's one place. Now, where do they intersect?
At -4, -3.
-4, -3. So look what I put right here. What is the solution to the system? -4, -3. I'm going to label it right here. This is my solution, that point right there. What does the solution mean? The lines cross. Where lines cross. Okay? So graphically, you just put both lines on there and you write down the point that they cross. Okay? All right, you try this one. Graph these two. Let's review these. Again, this other problem, the second question, everything was in slope-intercept form. What did I do with the slope on y2 to help me? What is the slope on y2?
2/1.
-2. And I wrote it as -2/1, so that helped me. I'm going to go down 2/1, down 2/1, but I got to catch that that's negative. So how many solutions are there? How many solutions are there on this problem? 1, right here. Here's your solution. Where is it? Where they cross. What point is that? The y-intercept, 0, 3. So here's the thing, guys. I'm going to circle this down here. This is the answer, okay? These points that they cross, the solutions, that's what we're solving for. So graph is like showing our work of how we got it. The actual answer to this question, if it was multiple choice or fill in the blank or whatever, we would be putting these ordered pairs. And it's just where they cross. Throw the graphs on, write down the ordered pair. Now, we're to the point where, yes, I'm probably going to have you put graphs on your paper or on your computer or whatever for check for understandings and stuff. But also, I want you to be able to do this using your calculator. We're at the point where we've done a lot of stuff by hand. Now I can show you how to use your calculators. Warning, these next 2 pages, there is a lot. There is a lot of writing. If you look at the next page, it's a whole calculator thing. This is for you to go back and refer to. I'm going to kind of make some notes on here, but it kind of overwhelms me because there's a lot of things. But this page isn't too bad. So the first thing we're going to do is we're going to do these problems. I'm going to label them 3 and 4. And we're going to do it graphically using our calculator. Okay, so I'm going to show you that you can do this without actually putting them on a graph. So here's our steps to do that. We need to make sure that both equations are in what form? Slope-intercept form. So fair warning, you are going to have to convert your equations to slope-intercept form a few times. And we'll practice that on some of the problems. Okay? So let's look at problem 3. I labeled it problem 3. Y equals 2x minus 4 and y equals negative x minus 1. Are both of those in slope-intercept form?
Yes.
Check, check. Okay? So now, step 2. Type both functions in your calculator. So get your calculator back out. Everyone, get your calculator in front of you. Go to the y equals button. And we're going to type our first equation in y1, 2x minus 4. And our second equation in y2,
How do you do X?
it's right next to the alpha button. Negative x minus 1. Okay, so you put them in separately, but they've got to be in y equals before you go to the y equals button. Does anyone need help typing these equations in there? We good? Okay.
Oh,
What? Are you good?
yeah.
Okay, so then step 3 is to click graph. Now, what I like about my calculators is that they're colored. So you're going to see one equation that is blue and one graph that is red. It doesn't matter if they are not colored. It still does the same thing. It's just you kind of know which one is which when they are. Okay, does y'all's graph look like mine?
Yes.
So let's just decide how many solutions are we going to have just looking at this picture. Are we going to have 0? Are we going to have infinite? Are we going to have 1? 1. We can see that they cross one time. They intersect. Everyone with me? Mohammed, you with me? Nick, you with me in your graph?
I'm with you.
Does your graph look like this?
No.
Okay, then you're not with me.
Well, then how do you do that?
That you're getting graphs that look like mine because you have to be careful with like negative signs and minus and stuff like that. So we got to be careful there. So we're now to step 4. Okay, here's the new part. We've graphed lines before, so here's what's new. All right, it's step 4. Please stay with me. You are going to press second, which is up here. Second. You are going to press trace, which is to the left of graph. It's up at the top. It's the second one from the left. Does everyone see what I'm pointing to? Press that button. And your screen should say calculate. Does everyone's screen say calculate?
Yeah.
And this gives you a bunch of things that by the end of the year, we're going to have done a lot of these. Okay? But for now, we're looking for the solution, the point that they cross, the point that they intersect. So what do you think we're going to press? 5. So you're going to choose number 5, scroll and enter or press the number 5. And then you are going to press enter how many times?
3 times.
3 times. Enter, enter, enter. And your calculator at the bottom left, when you are done, will say intersection. It will give you an X and it will give you a Y. And what is the intersection point?
1, -2.
1, comma, -2. And that is your solution. Dunzo.
Wait. Alright.
Your calculator graphed it for you and calculated the intersection point for you.
I accidentally pressed enter 4 times.
Did it go away?
Yeah.
Then just you have to do second trace 5 again.
Alright.
Okay? It's all in there. Second trace 5. 1, 2, 3. And if you press anything else, it will go away, but you just redo those steps again. Okay?
Makes sense.
That's easy, right? Calculator did it for us. All right, now let's look at number 4 right here. Are both of my equations in slope-intercept form?
No.
No. What do I have to do to get the first equation in slope-intercept form?
Convert.
Solve. First step. Have to move the
2x.
2x. How do I move it?
Minus.
Minus 2x. Minus 2x. Okay? So this will give me y equals -2x plus 5. Is it in slope-intercept form now?
Yes.
Yes.
Did I have to divide anything?
No.
No, because my coefficient of y was already a 1. So that was a really quick conversion. So here's your 2 equations. y1, y2. I want you to follow the calculator steps and do this one. So it looks like you guys are doing them right. Couple things. You've got to be in slope-intercept form first. Okay, so after you finish, all right, go away. You clear out your old equations. So I'm just pressing clear to get those away. And then I type my new ones. -2x plus 5 is my first one. Again, the negative sign is really only used at the beginning. After that, it's minus signs. This one is -3/7. Now, I saw several of you guys left off the X. That matters. It has to be. If you're going to use your calculator, you have to make sure that you're not making typos. You have to put it exactly how it is in the y equals form. So this is what your graph looks like. Again, we want to just get an idea. How many solutions are we finding? Infinite, 0, or 1? How many times do these cross? 1 time. So to go find that, I'm going to go to second, trace, 5, enter, enter, enter. Now, I did get a decimal here. That is okay. Decimals are numbers. It is not going to work out every single time that your lines cross at a nice, pretty, ordered pair. Most of the time, we set them up so that way they do. But it is possible, very possible, that they just don't. So we would write our solution. We'll round to the hundredths, which means how many decimals am I going to have? 2, because how many zeros are in 100?
1.
2. So I'm going to have 1 point. Now here's what I'm looking at. When I'm rounding to the hundredths, the third decimal tells me if I need to go up or down. So 909 means that 9 is going to round the O to a 1. So 1.91.
Does that still work with grading or not? Like if you have a
If you got a 90.9, I would put 91.
okay.
Yeah. Okay. And then the Y value 1.181. That third one is not going to bump up our 8. So we're going to put 1.18. And we'll just call it there. If you need to round, I imagine I will tell you how to round in the instructions. If I don't, that's something you could always ask. Okay?
I also got another question. Since
Yes.
It's like 5 or more raise the score.
Mhm.
90.
We're getting really close. All right? So that's how you can solve by graphing in your calculator. We've done it by drawing a graph, plotting a point where they cross, doing an intersection in our calculator. We already reviewed this in the warm-up, but I'm going to do a little squiggly line here because this is how we deal with tables. You got a table, line A, line B. Here's your steps to do regression. We've already done that. So we did this in the warm-up. So real quick, I want you to find for line A, the slope-intercept form. For line B, the slope-intercept form using stat. This is the stat thing, okay? Stat. Here's your steps if you're stuck. We did it on the warm-up. I want you to try this one on your own. Line A. What is the line A? Did y'all do stat? What'd you get for your slope for line A? That's the A value. Remember, they call it A when you do Lin Reg. And so that was A. For line A, what was it? 3. What was the y-intercept? They still call it B. So what's the equation? Slope-intercept form.
Y equals
3x minus 7. Very good. Line B, what was your slope? Again, your A value. -6. What your y-intercept? 2. That was your B. And so your equation is y equals... So that's how we write it. This is our system. I'm going to put this right here. This is our system, our 2 equations. They're both in slope-intercept form. So if you want to find the solution, we're going to do just what we did right above. We're going to put our 2 equations in where? Y equals, clear them out, clear out the old ones. 3x minus 7, -6x plus 2. Y1, Y2. We're going to graph it. We're going to see if they cross. If they do, second trace 5, enter, enter, enter. And that will give us our solution point. So on your test, I'm going to ask you, hey, write the system using your stat. And then I'm also going to ask you to solve your system by putting them in Y equals, second trace 5, enter, enter, enter.
That's a -7, not a -7.
Correct. The only time it would be a negative would be like in the slope.
Alright.
And I got an intersection point of 1, -4.
Wait, how do you clear the graph?
You got to go back to Y equals and clear out the equations separately. Yeah. Should y'all get 1, -4?
Yes.
Yeah. Very good. So I want you to remember that these calculator steps are here. Okay? So in your notes, if you're like, again, we're going to take like 10 days off for Thanksgiving break. So when we come back, like this is a good page to like, hey, I got a lot of calculator steps here. Do what?
Nothing.
You're not getting that?
No. That's it.
Okay. You get 1, -4? Flip, I'm not going to talk about page 8. It's a lot. There's a lot of words on there, but you can look at that. Okay, last thing we are going to do notes, and then you're going to do like 4 little questions for your homework is on page 9. Okay, so last thing we're going to do for page 9. We do need to talk a little bit about graphing inequalities. Okay, And we're going to be talking about shading here. You are going to have a small amount of inequalities on this test. There's not a whole lot of systems on STAR tests. Like we kind of just found like one per test, usually, give or take. I don't know, I say that, and then this year they're going to put 5. Who knows? But it is something that we wanted to teach because it is technically a system. So this is the last page of notes for today, so I appreciate your attentiveness. And then we have just a little bit of homework. It won't even be homework because y'all are going to get it done. Okay? All right, what's different about equations and inequalities? Equation has an equal sign. And then inequalities have a, what are our options? Oh, look, they're all right here. All those signs. Okay? Those are inequalities. Now, graphically, an equation will just be a line on a graph, no shade. Graphically, inequalities will be dashed or solid lines. And then what else do you have?
A symbol.
A symbol.
Greater or less than.
And then we're going to shade either above or below. Stop. We are almost done. Stop. Okay? In inequalities, where are your solutions located? Do you remember?
In the shade.
In the shade.
I thought I said
In the shade. Very good. In the shade or on a solid line. Very good. Okay, I want you to label each one of these inequality signs real quick. What they are right here.
like less than, like that.
That's going to go in the first column. Ugh, I have to write small. Line type and shade. Okay? Because we are going to graph these. So, just less thans and greater thans. There's no line there. So are these lines going to be dashed or solid?
Dashed.
So both of these are going to be dashed. Because there's no equal to. And if there is an equal to, then those lines will be solid.
Type of line.
That's fine. That's fine too. Dashed. Solid. Okay. All right, and then the shade. If it's a less than, where are you going to shade? Below. If it's a less than or equal to, you also shade below. But the other one, we shade above. Good. Y'all remember that a little bit. So, again, we want to make sure when we're graphing these that we're in slope-intercept form. So if we're not, like on the second one, we are going to have to convert it. We will do that in a second. But first, let's do the first one that's both in slope-intercept form. Okay? So the first line, where's my y-intercept of the first line? I know that got hole punched out, but that's a y. Y is what? What is this symbol right here?
Greater than.
Greater than. So if I look at this symbol, it is in slope-intercept form, so that is good. What type of line am I going to draw? Dashed. Why?
Because it doesn't have the equal.
Doesn't equal to, and my shade will be above. Dashed and above. All right, what's my y-intercept? Is this the same one that we did last time?
Yeah.
Okay, so my y-intercept is -9. My slope is -3/2. Remember, this is the one we didn't have room to go down, so we went up 3, left 2.
Miss McCartney, I have a question.
Yes.
Does it matter where you move based on the symbols? Like
From
when
point
it
to
comes
point?
negatives?
No. The symbol only tells you about line type and shade. The numbers are the same exact as they are in equations. They tell you how to move vertically and horizontally. So this line, was that what you were asking?
I guess guess, yeah.
Well, because the symbol doesn't have anything to do with the slope and the intercept. The symbol has to do with,
I'm saying when it comes to rise over run, could you go left or could you go below? Does it matter?
does this symbol affect up, down, up or
No, I'm
down?
talking about like rise, when it comes to rise over run.
The negative or positive does have to do with it, but the greater than or less than does not have anything to do with it. Because look, I need hang on the shading real quick. So I drew this was a dashed line. Here's what I do with the shading. I'm just going to draw some little up arrows for a minute, okay? Because what's different this time is that we're going to have two graphs on there. And when we find the solution set, we're looking at where the shading crosses, okay? So I got to get this other line on here before I can decide where my shaded region is going to be. So let's look at the other one. The symbol for the other one is less than or equal to. So what type of line am I going to draw?
Dash. And that's gonna be solid.
Solid. And where's my shading going to be? Below. So let's graph that. Up 2 for my y-intercept. My slope is positive 5 over 4, so that means I can go up 1, 2, 3, 4, 5 over 1, 2, 3, 4. Or, this is what I was talking about, Ethan, right here. I could also go down 1, 2, 3, 4, 5, and left 1, 2, 3, 4. Because a negative over a negative still gives me that positive direction I was looking for. And this will be solid.
Oh, I dotted it for some reason.
And my shading will be below. I'm just going to draw a couple down arrows there. And then for my solution set, I need to find where my arrows are pointing towards each other. Okay? So is my solution set, look up here, is it going to be up here?
Nope.
No. Only this arrow is pointing this way. Is it going to be over here?
No.
No arrows are pointing over there. What about over here?
No.
No. What about over here?
Yes.
So down and up, here's where my solutions are going to be.
Yes.
Oh, that makes sense.
Yes.
Where the double shade is.
That does make sense. What if they're both like shade on top,
Uh-huh.
like parallel, and then like that?
If they're like this and they're both shade on top,
Yeah.
then the solutions will be up here.
Oh.
Because this doesn't have double shade. This would have double shade. Okay, so here's our solution. So write 3 points that are possible solutions. Let's y'all look up here. I'm going to point and y'all are going to tell me yes or no. Is this a solution point? No. Is this a solution point?
Yes.
Why?
Because it's on this.
It's on a solid line. Is this a solution point?
Yes.
Is this a solution point?
Yep.
Is this?
Yep.
Is this?
No.
Is it on a solid line?
Not dash.
It's on a dash, so that is not a solution point. That's a no. Okay? So write 3 points that are somewhere in the shade. I don't know. We'll do 2, 1.
That one. That one.
What's this one? 7, -5. And then I'll do that 0, 2. You can pick your own points. It's up to you. All right. Last one.
Is that it? Like,
This will be...
Is it homework?
What? There's 4 problems, yeah. 4 problems. But they're ones you can do in your calculator. So they're pretty easy. No, you'll do it. You'll have time. You'll have time. No, you'll have time. All right, let's look at this one right here. Okay? All right, what's wrong with this one? Star this.
It's in standard form, not in negative.
They're not in slope intercept form. All right, so I will make you a deal. I'll do one of these with you, and then you do the other one. I'm going to do this one with you right here. Let's look at 6x minus y. Okay? I picked this one for a reason. We got to convert this. So what's the first thing that we got to do?
Minus it on both sides.
Minus what?
Or x 12x on both sides.
No. I'm doing this one first. I'm doing the second one.
Oh.
I'm going to have y'all do the other one on your own.
Minus x.
Minus 6x on both sides. Okay? Now, what's in front of that y?
1.
Negative. And if you want to write in a 1, I think that's helpful. It's like a -1 is right there. greater than negative 6x plus 4. Make sure you guys are really flipping the sign of the x because that is something that we've been struggling with. Now, what am I going to do to get y all by itself?
Divided it.
By,
-1.
okay, look right above in the box. What did I put in your notes? So what's going to happen to my inequality sign of a greater than? Going to become a less than. And then this is 6x minus 4. All right, I put a star by this problem. Most of the star questions that I saw over inequalities did make you convert. And some of them did have where you would divide by negatives. So let's graph that real quick. -4. Our slope is 6 over 1. So up 1, 2, 3, 4, 5, 6 over 1. 1, 2, 3, 4, 5, 6 over 1. What type of line is it going to be?
Dash.
And the shade is
But yeah, above.
below.
Below.
Remember, because it flipped.
What are you doing, Joel?
Drink.
All right, now you guys convert and graph the other one. Okay, apologies. This graph got really weird. Did y'all get the same slope-intercept form that I did
Yeah.
They touch it, right?
for here? Yeah, they're very close, but both the shade is pointing down. So we need to shade below both lines. And so it's going to be starting at the dash line. It'll be here, and then it's going to kind of switch, and it'll be, but this is your solution set. That's really weird. Sorry, these graphs were probably a mistake, but it's okay.
That's it.
But that's it for the notes. So I passed out this little puzzle thing. This puzzle packet kind of has the rest of the homework for the whole unit. You are only going to do puzzle 1 today, and it is really quick. Okay, so you can get it done. You are going to need to match each question, each system. Make sure you understand. You're going to need to match with a graph. Are you listening? So you're going to need to match a graph. Here's a system, which graph matches, and you can use your calculator. And then you're also going to find what solution point. So then to get the code, you're just going to go in order. Graph solution, graph solution, graph solution, graph solution, and it will spell out a word. Okay?
We only have like 10 minutes to do this.
Yeah, it won't take that long. You got a calculator. So this is your homework, is just to do puzzle 1, and then don't lose these 2 packets. Bring them with you after a break. And then when you're done, bless me. When you're done, bring it to me so I can check it.